Hello everyone. Today's class is about abstract data types or those data types which are different than arrays and variables. Or we can say that those data types which can hold data and to keep the data related operations as well. So abstract data type is a data type that holds the data and all the operations related to that data. So there are three abstract data types that we would have to study. There is only introduction in AS and in A2. In P4, we will have detailed discussions of abstract data types. As far as programming of abstract data type is concerned, we will not have to do a lot in this case, only the basic related programming which is most necessary for the introduction of ADTs is required, whereas in P4 we will be doing um, in-depth programming for ADTs and the variety of ADTs, as in A2. In P4 we have more ADTs than these three. So the three ADTs that we are going to study today, as I said, is stack, queues, and linked list. So first let's see what is in the syllabus. It is 10.4 in 9618 syllabus. That is Introduction to Abstract Data Type ADT. Show understanding that an ADT is a collection of data and a set of operations on those data. Show understanding that stack, queue, and linked list are examples of ADTs. Describe the key features of stack, queue, and linked list and justify their use for a given situation. Use a stack, queue, and linked list to store the data. Candidates will not be required to write pseudocode for these structures, but they should be able to add, edit, and delete data from these structures. What does that mean? It means that you will not be asked to write the pseudocode for the operations over these ADTs, but you are expected to pictorially and conceptually do whatever they ask you to. All right, so we will look into it. Since there are no questions, this topic has floor crossed from P4 into P2 this year. We are not having any questions at AS level or P2 level, but we would have so many questions from P4. So all those questions which are just concerned about the concept of these ADTs and not the programming, we will all try to solve those. Let's see. And describe how a queue, stack, and linked list can be implemented using arrays. So this is another thing. As we know that array itself is a data structure that holds the data, but it is a simple data structure that holds the data in many elements. And if we use this array as stack, queue, and linked list, then we would have to actually add those functionalities which are required by stack, queues, and linked list to these arrays in order to treat these arrays as stack, queue, or linked list. So let's start with stack. Conceptually, stack is a data structure which is having only one end open and the other end closed. So there is just one end from which you are entering the data and you are having the data back. So it's like a glass or a cup or a simple stack where when you put items on top of each other, the item underneath cannot be removed until all the items on top of it are removed. So what does that mean? That a stack is a data structure that is having one end open and all the items can be entered and removed from that one end. And technically, as you can realize yourself, that when the item is added, it will be placed on any other item which was added before it, or if there is no item in the stack before it, it will get settled at the bottom. So this is a data structure stack that is considered to be something like a utensil, a glass, or a cup that is having only one end on top opened, and all the items which are inserted are stacked upon each other. That is why we call it stack. And we cannot have an item removed until all the items on top of it are removed before it. So what does that mean? It means that in order to have an item, you would have to remove all the items on top of it. So technically, the item that was pushed at the end can be removed first. So that is why we call this data structure last in, first out. This is the operation of this data structure. This is the nature of this data structure, that the item that you have pushed in the last will be removed first. Now, the action of adding data to this stack is called push, and action of removing the data from the stack is called pop. So the item that is pushed will be pushed on top, and the item that is being popped will be popped from the top. So last in, first out. So in a stack, we don't have any data structure that exactly represent this style of holding the data, but and not just this style, but holding many more data items this way. So we use what? An array. We use what? An array. So when we like to add data to this array, we will have to keep all the formalities of adding data to stack and all the rules which are basically followed by the stack. So in that case, if we add as in push and remove as in pop data, keeping all the rules of a stack into consideration, then that array will be called stack. All right. So the stack is a conceptual data structure that is being practiced using an array. Stack is a data structure that is being practiced using an array. By having the word practice, all I mean is applying those operations which are necessary to control the stack array. Now, so let's say that we have got a pointer which is the top pointer. That pointer will move only when a new item will be added. So it means at the start, this top pointer will be at the base. What is the base? 0. Now there are two ways handling arrays, in AS mostly the array elements are starting from 1 as the lower bound, and in A2 in P4 mostly array elements are starting from 0 as lower bound. So it really does not matter. So whatever that you would have in exam, it will be clear in it that whether your low bound is 0 or 1. So over here I have considered it as 0, meaning the first element would have the index 0 of this array. So the top pointer will be at the base, which is lower bound. Once we like to add to this stack, we will have to first add 1 to top pointer. So top pointer will be actually uh, at the base. Now, below the base, rather, uh, it means that if the lower bound is 0, top pointer will be -1, and if the lower bound is 1, then the top pointer will be 0. So you would have to add 1 to top pointer first. So top pointer is equal to top pointer plus 1. In that case, top pointer from -1 will become 0, and at that particular element where the top pointer is pointing to, we will add the data item that we want to. Then we like to add another data item, then we will add 1 to top pointer first, top pointer will become 1, and then we add the second data item at that location, and then we add 1 to top pointer. Now top pointer is basically pointing to 2, and then we have added 82 to it, and then we have added 1 to top pointer, and it is now pointing to 3, and we added 95 over there. So this is the situation that this is an array whose name is the stack. It has got 7 elements from 0 to 6, but the data that is being added is added as per the rules of stack. There is one top pointer that is basically helping the developer, the programmer, to keep those rules intact, which are the rules for stack. So whenever you like to add, you will only be adding until the top pointer does not reach at the upper bound, because we have as much space available. So let's say this is the current situation, that top pointer is pointing to element number 3, and there are 1, 2, 3, 4 items already added, and now we are moving towards 2. We have removed one of the item from the stack, and as I said that when we remove from the top. So the top element which will be removed is 95. So what we will do, we will read from the top pointer and then we decrease the top pointer. So this 95 will be removed. Over here, this 95 is now removed and top pointer has gone down to element number 2. Whether you see 95 over there, since top pointer is not pointing at 95 at element number 3, this 95 will be considered as removed. So this 95 is now popped. Top pointer gone back one position, and now top pointer is pointing at 82 at element number 2. So this is a pop. Now let's push one item. You see, now the current position of top pointer is 2. When we would like to push a new item, we will increase the top pointer by 1. It will be pointing to 3, and the new item that will be placed will be at element number 3. And now this is called push. Afterwards, this would go on and on and on until the top pointer reaches to the top. So let's see, there are few terms attached. First of all, This is an array whose name is stack, having 7 elements from 0 to 6. Now I have made few variables like stack full. When will be stack full? When there will be 7 elements. Top pointer is -1 at the start, and there is a term that is called overflow. What is that term? It means that when we like to add more item to stack, and if this top pointer is already at position number 6, we cannot add more item as there is a physical limitation. All right, most welcome, and I hope that you will have more um, facilitation from these videos, and I hope you will get good result in your CIEs as well. So what is an overflow? Overflow when we try to add more items and there is no space in a stack, which is an array. Underflow is when you try to pop and the stack top pointer is -1, means there is nothing there. So what is push? That is simple. Increase top pointer, add item at top pointer location. What is pop? Read the data which is at the top pointer location and decrease the top pointer. And this stack full top pointer, they both are basically global variables so that they can be accessed by any subroutine which is there for data manipulation. Now, as I told you that ADT, abstract data type, is a data structure along with all the operations. So now you need to understand that this particular data structure, which is stack, is basically an array. That array has to be in global space so that it is available to all the subroutines, and these subroutines will be what for push and for pop and for maybe for the display of the um, array elements. So now by saying that, what I mean is very simple, that top pointer, stack full, base pointer, although we don't need base pointer, but I have deliberately used it over here. You can remove it, and the array, which is a stack itself, is basically in the global space. All right, then we are required to basically create this array and these 3 integer pointers in the global space. Then we will have to actually initialize these integer pointers, and then we will have to actually initialize the whole array. So array is, over here we have considered this array as an array of integer elements, and then we have got first procedure, which is basically push. This is a procedure that push an item to the next available element in the array. Now, this push naturally requires one item to be added. Either you can capture that data item and transfer it as a parameter to the push subroutine or procedure, or you basically can write a prompt and input routine inside the push procedure itself. It's totally up to you, or the nature of the question that you would have, and fortunately you would not have any pseudocode writing. So if they require, they might give you a pseudocode to read out, so you would have an idea that how the whole thing is being exercised in the question. So procedure push, it receives an item. That item needs to be added to the next array location on top of stack. Now, first thing I told you that there is a term which is called overflow. Overflow means what? Overflow means that you don't have any more spaces in the stack and yet you are trying to push one. So in that case, you would have to actually report overflow. So if the top pointer is less than the stack full is what? Stack full is basically 7, means there are 7 spaces. In that case, it means that we have got space to push new item, and if the top pointer is less than a stack full, then top pointer is equal to top pointer plus 1. We increased top pointer, and at the new location of the top pointer in the stack array, we have saved the item. If the top pointer is not less than a stack full, as in it is at 7 or above it, in that case, system will jump to else part and it will output overflow occurs and cannot push. All right, so it cannot push, and then that's it, end of the procedure. Now pop, in pop basically what do we have to do? We have to actually return the item at which the top pointer is pointing to. The item, the array element item, the data that is saved at that particular location. So this is naturally a function because it is returning the value which is saved at that particular array location, which we are treating as stack. So I told you about one of the terms which are called underflow. Underflow means what? There are no items and yet we are trying to pop one. In that case, underflow error. That this is error. Underflow and overflow are what? Errors. So when we push, we might have overflow. Similarly, if we pop, we might have underflow. So we have to take care of that underflow thing first. So if the top pointer is less than base pointer, what was the base pointer? 0. Base pointer was 0. So if the top pointer is less than base pointer, in that case, you would have to actually output that underflow occurs, we cannot pop anymore, and we return -1. So this when the calling subroutine or the main subroutine, when it actually has this -1 back, it would know that this is an underflow occurred. Otherwise, we would have a value that would be returned. Else, if it is not underflow, in that case, whatever the item or the index towards top pointer pointing to will be saved in item, a variable, a local variable, and then that particular location will be cleared up. Nothing will be there then anymore, and the top pointer will be reduced by 1, and afterwards that item in which the data got saved, which is meant to be popped, will be returned to the calling subroutine. All right, so now let's actually Arham Khan. So base pointer only acts as a flag for the first item in the array. Yes, exactly. We don't need it. If you like, you can. Otherwise, we can always check it with 0 or 1, whatever is the first item index. Yes. Wonderful, Arham. Now, let's see this program in action. All right. I have written this pseudocode, sorry, this Visual Basic source code without considering any extra pointers or anything to keep it simple and as innovative as possible. Okay, we don't need this. All right. So this is Visual Basic code. First we have described, we have declared an array of 6 locations. All right, and we are actually, hold on. Okay, and we use this 6 as the top of a stack. This is a character array, means we are going to input characters, and top of the stack pointer as integer. So in the main program, we have first called a subroutine called initialize. So as I said, that stack ADT is abstract data type that is describing that how to hold the data and the operations related to that. So I have got 2 additional operations like display stack and initialize. So in initialization, all the elements of the array are being initialized to null since these are characters. And remember, in Visual Basic, we use double quotations for characters, while in pseudocode, we use single quotations for characters. So now, this initialize subroutine, what it does, it actually initializes the array and the top of the stack pointer. So top of the stack pointer is 0. Now, after calling initialize, a menu is being presented to the user for pushing to stack. Copying from the stack, and then if they want to exit the program. And then there is a validation check, range validation check, that makes sure that whatever the number of the menu that you enter must be between 1 and 3. And as you would already have this knowledge that this is basically repeat until loop. In Visual Basic, we don't have such words as repeat and until, rather we have do, loop, until. If it is in pseudocode, this would be repeat and until. So here in pseudocode it will be repeat, and over here it will only be until, otherwise it is the same. So we are presenting with the menu and then a prompt to enter the values from 1 to 3. And remember that this code is written in inspiration with the marking schemes, all right, and the past papers. I hardly write or teach anything or any source code which is actually from myself. I take all my inspirations when writing the source code from the past paper so that I could be as close as possible to the CAIE standards. So now, after this validation check, which makes sure that you enter the value from 1 to 3, then we would have the value taken into the choice variable. So if you have made the choice 1, it means you want to push to the stack. So then we have used case and end case, which in VB is called select case and select. So if the case is 1, it means that we like to push to the stack. In that case, we present our user with a prompt to enter the character to push on the stack, and then we take that input into the value, a variable, and then we call push procedure with the parameter which is the value that we like to push to the stack. Then if you have chosen number 2 for the pop from the stack, in that case we actually call the pop function, which when return the value which is popped from the stack will be saved in the value. And if that pop function have returned a null value, that means that the array was empty and an underflow is occurred. So in that case, we will give this message to the user. Otherwise, we will tell the user that this is the value that we have popped. And then we call the display stack. All right. The subroutines over here, the procedure for push and the pop are pretty much the same as we would have discussed in the pseudocodes, but I would like to discuss this fourth subroutine, display stack, where I have tried my best to make things as clear as possible. So I have made this arrow to actually show where the top of the stack pointer is present at the moment. So let's execute this code. Now, there are 3 options presented. So I would like to, let's say, what if we try to pop right away? So it value that is popped is nothing. All right. Top of the stack pointer is 0. Now, what if we like to push? So enter character to push on stack. So let's say I have pushed A. So now you can see that the stack has one data item and arrow is pointing towards it. This is what I was talking about when I was discussing this display stack subroutine that I have written. And again, I like to push B. So in that case, you can see now the stack has A and B, and the top pointer is at B. And then I would like to push C. So now the top pointer is at C. Now let's pop 1. So obviously the C was the last item, as the principle of a stack goes last in, first out. The last value that was entered is C, so C is popped. So now you can see that C is popped and arrow is now pointing back to B. So if you now top of the stack pointer is at 2. So 1, 2. All right. Now, if we push again with an item D, so that C, which is treated as deleted, will be overwritten with D. So now let's see if the overflow error occurs. So D, then we push E, then we push F. How many items are there? 1, 2, 3, 4, 5. Now, there is one more item that we can push. 1, F, and G. Now this is 6 items, 1, 2, 3, 4, 5, 6. That is the top of the stack. And if we push any more H, so it will say overflow stack is full, no more values can be added. And if you like, you can see the top of the stack pointer is 6, and 6 is the top of the array as well. It means we cannot add any more values to it. And then if you like to pop, you will pop G and F, then E. Let's try that. See, G, then F, then E, and that is how you will be able to pop all. So this is a program. This program is actually available in GitHub account. If you do remember, I told you that my GitHub account is present at ZAK on web handle over the GitHub. So it is github.com/ZAK on web. And here are the repositories that I have: pre-release material, computer science, string manipulation AS, and data structures AS. There we go. Data structures AS. Over here we have got stack and stacks class boards and simple stacks. Here is the Visual Basic program, all right, that you had just seen. And then we have this in Python as well as in pseudocode. So this is a stack. Now let's wait until we solve past papers for a stack. My plan is to first finish all 3 data structures and or abstract data types, whatever you call them, and then we basically solve all related past papers. So now Q. Q is another data structure, and like stack, it has few rules as well. Now, Q is also implemented using an array, as this is basically another conceptual data structure. By saying conceptual, we mean that there is nothing physical in any language that actually mimics the queue. So we have to actually utilize available data structures and write operations related to those data structures concept to make the whole thing being treated as queue. And that is what the real essence of ADT means. These ADTs are the means of holding data along with the related operations. Those operations work in tandem with the concept of that particular data structure. Now, thank you, Mohammed Moazzam. So now Q is a queue. We know what queue is. This is a queue like we have a queue at box office, at the cinema, we have a queue in the assembly in morning at a school, or we have a queue at a bus station to get on board bus or whatever. The queue is always queue. queue has one thing. What comes first is treated first. So first in, first out. First in, first out. It means it would have two ends. A rear end, from there everything is being entered, and the front end, from there everything is being going gone out. So first in, first out. It's a queue. So this is sort of tunnel where the car that enters the tunnel first will get out first. So how do we actually mimic this queue and its functionality as in first in, first out thing? Sorry for the disturbance. I don't know, something has happened. Now, as I said, queue is a data structure that allows the data from one end and it let the data get out in the order of entrance from the front. So it has got two ends, the rear and the front. So we need two pointers. The front pointer, from which basically the data थोड़ा सा होल्ड कीजिएगा.